Hello everybody, in this video we're going to go over Pythagorean theorem converse. We're going to go ahead and discuss how to approach these problems, and right now I have a problem right here for you to go and check out. So in this case what we're doing is that we have to be able to solve for the missing, we have to go able to solve for whether it's acute, obtuse, or right. But a lot of the issues is that a lot of students see this and they get confused with that. So one way to approach it is that you can type that into the calculator and then see what pops out, okay? So in this case, when you typed it into the calculator, we ended up getting 6.28, okay? Now, now we can identify which one is going to be our C, and in this case, C happens to be the 13, okay? Now, from here, all we just did is just replace the C where it's at, and then everything else kind of just falls where it needs to go. Now, I do want to emphasize this one right here. So you want to be able to use the radical itself. Do not use the decimal, okay? So we want to be able to practice our radicals and how we're multiplying them. So in this case, we have 4 square root of 3. That happens to be our A that we have. It replaces it. So when we write it, we want to be able to double that figure or double that radical. And by doubling, it's like saying 5 squared. When you have 5 squared, we all know that's going to be 5 times 5. So same thing over here for whenever you have the 4 root 3. It's saying is that we're multiplying the 4 square root of 3 times another 4 square root of 3, okay? Now, from here, we just want to be able to isolate the 4s that we got going on, because outside multiply with the outside, which is going to be 16, and the insides multiply with the inside. So in this case, it's a 3, and then you have a 3, and that'll be the 9, okay? So the square root of 9 gives you 3, and at the final end, what we have is going to be 48. Okay, so here, all this right here goes back to our radicals that we did with tree method, or understanding how they multiply. Okay, so then if you understand how to go ahead and use your square and multiply your radicals, great. If you don't understand that, then obviously just keep practicing, and then it will come with time. You can also check out the other video for how we multiply these. Now, you have square root of, 48 right here. So everything else kind of gets squared because we have this 11, and the 11 gets brought down here. Add them up at the very end of it together, and then you get 169. 169, after you square that 13 over here, okay, you get 169. So in this case, it'll be right, okay? So that's one way of going about it, okay, in terms of like wherever A is going to have the 4 square root of 3. Whenever you have one of these right here, like 18, just know that we have to be able to identify which one is C, and I don't know which one's C right now, okay? So I'm going to go into my calculator, and I'm going to go and type in the square root of 93. And the square root of 93 is 9.6. So this is 9.64, okay? And so that makes this one C, okay? So C is going to be my 11. So I'm going to go in here. I'm going to go and write it in here. Okay, so B squared equal to, is going to be C squared. And when you write it in there, you get 11 squared. And that's going to go ahead and be 121. And when you write this in here, you get 5 squared. But 5 squared is already 25. Okay. And then I'll make this one my B, and that's my A. So now you get the square root of 93 squared. Now remember, when we did the radicals, we went over radicals, we had a shortcut. This square and that square root cancel. They're opposites of each other. So they're going to cancel out, and what's left over is just a number. So in this case, we have 25 plus 93, and that's equal to 118 versus the 121. So which one's bigger? Okay, the bigger one is going to be 121, and so in this case, it'll be obtuse, I believe. Okay, so just be mindful on how to set these up, okay? Try it out, follow the steps, and then go from there. All right, there you go. Tune into the next video.